Now, regression trees. Now, the decision tree, typically the target is nominal, right? It's either binary or a nominal target. But what if the target is an interval target, like the Toyota Corolla data set, where we looked at the uh, sales price as our target? So if you have a interval target, then how can we use the decision tree? Well, um, you don't need to change anything. You use the decision tree exactly like it is, except when you come down to the rectangles, instead of looking at the class purity, so you will look at the average value. Okay, so for the purpose of branching, you'll use mm, uh, root mean square error. Okay, and for the purpose of prediction, you'll use the average of each of the rectangles. So used for continuous outcome, procedure is similar. Many splits attempted. Choose the one that minimizes impurity, and here impurity is measured by root mean square error. So if you have the target variable in one branch, they all have the same price. So for example, in Toyota Corolla example, if all the observations have the same price, then the root mean square error will be 0. So impurity is 0. So maximum purity. So purity will be measured by root mean square error. So prediction is computed as the average of the numerical target variable in the rectangle. So impurity is measured by sum of square deviations, which is the square of, so RMSC is the square root of sum of square deviations. Now, to summarize, advantages of decision trees: it's easy to use. It gives you the classification method is given to you as a understandable rule. So anybody can look at the rule and understand what the rule means, and you can apply. Easy to interpret and easy to implement, and you can use this methodology for variable selection and the variable reduction, which is automatic in the methodology itself. So if you have hundreds of variables, thousands of variables, you don't need to first do variable reduction. Okay, the method itself will perform the variable reduction for you, and if the variables are correlated, it doesn't matter. So like in regression analysis, if there is correlation among the predictors, it will lead to multicollinearity. No, there is no problem here about that, because we are not looking at the correlation among the variables. So they do not require any assumptions, and it can work even with missing values. You don't have to impute missing values. All of these are advantages of decision tree. For these reasons, decision tree is a very popular classifier. But there are some disadvantages, of course, because the number of possible splits can increase exponentially if you are not careful. So if you have an interval predictor with lots of different values, it's a good idea to bin them into classes, so the number of possible splits is kept to a minimum. Since the process deals one variable at a time, as in regression analysis, interactions can be coded and captured. So two variables may produce an interaction effect, but interaction effects cannot be captured in decision trees.